Hey kiddos, welcome to lesson 1. Today we are going to be learning about ratios and rates. Our lesson goals for today are to learn how fractions, decimals, and percents can be used to represent ratios and rates. Today you're going to be learning how to compute unit rates, including ratios of lengths, areas, and other quantities measured in like or different units. Our vocabulary for today is the word ratio. A ratio is something that describes the relationship between two quantities, and it can be written as a fraction, a decimal, or a percent. The second vocabulary word is unit rate. A unit rate is a ratio that has a number related to 1 and a proportion. Proportions are equations that show that two ratios are equal to each other. We're going to talk a little bit more about the resources at the end of this lesson. So let's get into it. Ratios compare two like things. In this particular illustration, we are comparing circles, different colored circles. On the left-hand side, you can see that we are comparing green circles to red circles. And we could write that comparison of green to red circles as 2 to 3. In the second example on the right, we are comparing 3 different things. We are comparing red circles to blue circles to green circles. And we could use the comparison of red to blue to green as 1 red to 2 blue to 1 green. Ratios can be written in 3 different ways. We can write a ratio as a fraction, and this is probably the most common form that we will be using ratios as when we are working in math classes. Fractions are the easiest for us to work with, to add, subtract, multiply, and divide. However, you can also write a ratio using the word 2. And finally, you can write a ratio with this colon. And when you read that sentence out loud, you would read it as 12 to 1. So you're still using this word 2, even when you're reading any one of these ratios. When we write a ratio, we want to make sure that we write it in simplest form. Most of the time, like I said, we're going to be writing ratios as fractions. So it makes sense that we're going to always want to take our fraction and simplify it. In this example, I want you to use the following table given to create a ratio comparing the green marbles to the total number of marbles. I want you to write that as a fraction, and then I want you to write it in simplest form. So the way that I would do that is I would use this chart, and I would find the number of green marbles, which is 36. And then I'd want to compare that to the total number. So what I could start by doing is I could start by creating a fraction with words, right? I could start by comparing green to the total. Now this fraction is just going to help me make sure that I'm putting the numbers in the right places. Okay, so the number of green marbles in this particular chart is 36. And the total number of marbles in this chart is 54. And that's right here. Okay, so what I just did was I created a fraction, which is also called a ratio, that represents the number of green marbles compared to the number of total marbles. So that is 36 to 54. And you can see that fraction written right here. Right, now that is a ratio. However, if I wanted to take that ratio and I wanted to write it in simplest form, I would divide both the top and the bottom numbers, my numerator and my denominator, by the largest number that divides into both. You may not have thought of 18, but 18 is the greatest common factor. So if I divide 36 by 18, I get 2. And if I divide 54 by 18, I get 3. So the ratio of green marbles to the total number of marbles is 2 to 3. And that's how I would read this answer. We could also say that answer in a different way. And we could read that answer by saying, for every 2 green marbles, there are 3 total marbles. And that's an example of a ratio. Folks, just to make sure you know, you are more than welcome to simplify in a different way. For example, if you started by simply dividing these both by 2, you would have ended up with 18 over, not so good with 54. I could go ahead and divide it by 2. And at this point, you could be using Desmos if you wanted to. 2 goes into 5 2 times. 2 goes into 14, 7. And so my answer would be 27. Okay, but these can still be divided. I can continue on. I could divide these now both by maybe 3. Maybe you could see at this point that 9 goes into both, and you could divide these both by 9. You could break it into pieces. You don't have to divide by the greatest common factor. You can break it into steps. In any case, I'd end up with 2 over 3. Okay, so again, that ratio represents the comparison of the number of green marbles, which is 2, to the total number of marbles, which is 3. There are other ways that we can solve ratio problems. And in this particular case, we are being asked to find the amount of barbecue sauce needed when 10 cups of water are used. So let's take a second to look over here at this table. And on the left-hand side of the table, we are told the number of cups of water, and it is being compared on the right-hand side of the table to the number of cups of barbecue sauce. Okay, so let's just make sense of what this first row represents. In this first row, they are telling you that for every 2 cups of water, you would need 5 cups of barbecue sauce. All right. And in the second row, what they are telling you is that for every 4 cups of water, you would need 10 cups of barbecue sauce. Now, the question asks you how much barbecue sauce we need when there are 10 cups of water used. So we are trying to figure out what number goes down here in this bottom box. And there are a lot of different ways that we could come up with that answer, but you could see in this particular visual representation, we could base this idea by figuring out what the pattern is, right? So if you notice by looking down the left-hand side of your table, that these values or these numbers are always increasing by 2. We could add 2 to each of these numbers to give us the number 10. And then if we look down the right-hand side of the table, we could try to find the pattern there. So to get from 5 to 10, I'd add 5. To get from 10 to 15, I'm adding 5. To get from 15 to 20, I'm adding 5. So to get from 20 to the last number, I would add 5. And that would probably pretty easily allow me to find out that for every 10 cups of water, I would need 25 cups of barbecue sauce. That is one way that we use ratios. We want to relate two like things to each other. All right, let's practice with it. This would be an example of a homework question you would get. It says the Callahan family has 2 dogs and 5 cats. All right, so you can see that that representation is being shown over here visually. The 2 boxes represents the number of dogs that the Callahan family has. And the number of cats they have is represented by those boxes as well. So you can see that there are 5 cats. Okay, we could write that ratio of dogs compared to cats as a fraction. We could write it as for every 2 dogs the Callahan family has, they have 5 cats. All right, so that answers letter A. What is the ratio of the number of dogs to the number of cats? We could write it, remember, in 3 ways. We could write it as 2 over 5. That's the most common in math. We could write it as 2, then the word 2, 5. Or we could write it as 2 and then using the colon symbol, and we would still read it as 2 to 5. So we could represent that answer in any of those three ways. Question letter B asks us, what is the ratio of the number of cats to the number of dogs? In that case, what we would need to do is make sure that when we are setting up our relationship, we would put cats in the numerator and dogs in the denominator. Okay, because cats came first and dogs came second. So cats goes in the numerator and dogs goes in the denominator. The number of cats that the Callahan family has is 5. The number of dogs the Callahan family has is 2. We could also write that as 5 to 2, or we could write it with the colon as 5 to 2. Notice that the order matters. It is really important that we are reading the question carefully so we get our ratio in the correct order. Okay, finally, let's look at question number C. It says, what is the ratio of number of cats to the total number of cats and dogs? Well, that second piece of information isn't given to us. We're going to need to do a little bit of math to be able to get the total number. But what we can do first is we could set up our fraction. We could say we are going to compare the number of cats to the number of total animals, cats and dogs combined. Okay, so I could very easily go over here and look at my visual representation and figure out that there are still 5 cats. That hasn't changed. But to get the total number of animals, I would add the number of dogs plus the number of cats. So to get my total, I would add 2 plus 5, and that would give me the total number of pets in the Callahan household, which is 7. So the denominator of that fraction now would be 7. So the ratio of the number of cats to the total number of cats and dogs would be 5 to 7. And again, for the last time, I could write that in 3 different ways, but they would all be read 5 to 7. All right, people, we're going to move into the second part of this lesson, which is called rates. So a rate is a ratio that compares 2 different kinds of numbers. So when we were working with ratios, we were always comparing like things. So for example, we were either comparing marbles to marbles, blue, green, red, or we were comparing cats to dogs, which are pets, right? They were comparing 2 like types of things. Once we start talking about rates, a rate compares 2 things that are different, such as miles per hour or inches per second. Okay, and the 2 visual representations I'm giving you are donuts per money, right? 10 donuts for $13. So we're comparing donuts to dollars. And in the example on the right, we would be comparing our number of ounces to the number of dollars. Okay, so if we were to set up fractions for these, they might look something like this. We might say donuts compared to money, dollars. And in the situation on the right, we might compare the number of ounces. And remember, ounces, when we abbreviate it, is OZ. That's what this is. That's the abbreviation for ounces. So we could compare ounces to dollars. All right, and so what we're going to do, that's called a rate when we compare 2 things that have different units of measure, and we're not comparing marbles to marbles. That would be a ratio. Ounces to dollars would be a rate. And oftentimes what you're going to see happening when we are dealing with rates is that we are going to want to find what is called a unit rate. Now, a unit rate is the same type of thing as a rate. It still compares 2 different quantities, but it compares it to its unit of measure. And what that means is that we are comparing something to 1. Okay, we want to make sure that when we are using a unit rate, it is comparing something to 1. So what does that mean? Well, if you look at this example, you could see on the right-hand side that I have a speed limit sign, and it is telling me that when I'm driving in my car, I'm allowed to drive 35 miles per hour. I can go 35 miles in 1 hour. Okay, and that could be written as a ratio or as a fraction, excuse me, not as a ratio, as a fraction. Let me start it this way. I could compare miles to hours. All right, and in this case, I would be comparing 35 miles in 1 hour. All right, this is what we call a unit rate. It's because our denominator is 1. And that's called a unit, a single unit. When you were back in first grade and second grade, you might have been using those Unifix blocks where you would stack them on top of each other and make groups of 10. We call those Unifix unit, okay, because it means 1. So when we have a fraction where the denominator is 1, we call it a unit rate. Unit rates are very important because they will allow you to compare things that are difficult to compare. I'm going to show you a lot about that in another lesson. Okay, so if you were asked to find the unit rate, we would use what's called a proportion. Okay, a proportion is just 2 different fractions that are set equal to each other. Let's take a look at this problem, and I'm going to talk you through what a proportion is and how to use it. All right, so this particular problem says that Joey has a toy car, and his toy model of his car is powered by sugar water. If the car goes 25 inches per tablespoon of sugar water, you are being asked to find how far it can go on 5 tablespoons of sugar water. Okay, so the first thing that I would want to do is I'd want to reread that problem to myself to make sure it made sense to me. I'd read it again. It says the toy model of Joey's car is powered by sugar. If the car goes 25 inches per tablespoon of sugar, how far can it go on 5 tablespoons of sugar water? Okay, so what we are going to do is we are going to set up what's called a proportion. So the first thing that I want to do is I want to create that comparison fraction. I want to say what it is that I'm going to be comparing. So I'm going to be comparing the inches that the car can go to the number of tablespoons. Now, tablespoons is TBLS abbreviated, okay? I'd write it out, but it'd take me too long. So this fraction shows what I'm going to be comparing. I'm going to be comparing the inches to the number of tablespoons. And now I'm going to go ahead and set up my 2 different fractions by the information that was given to me over here in the problem. So the first thing that I know is that it goes 25 inches per tablespoon of sugar. All right, that's the first piece of information I'm given. So my first fraction is going to show on the inches, it goes 25 inches. And for the tablespoons, it says per tablespoon, that means 1. For each, per, those are all words that tell you that you're using 1. Okay, then I'm going to create another fraction, and I'm going to use the second piece of information given to me in this problem, which is the 5 tablespoons of sugar water. All right, so again, when I'm using my setup over here of inches to tablespoons, I want to make sure that I'm putting the numbers in the right places. So notice that I am given 5 tablespoons of sugar water. That is going to go in my denominator because that's where my tablespoons are. All right. And I don't know how far it can go. I don't know how many inches it can go. That is my unknown. So I can either put a question mark there or I can use a variable. All right, what I have just done right there is created what is called a proportion. I have set 2 fractions equal to each other. And this is a proportion. And we use proportions all the time in math to help us find an unknown value. Right, there are 2 different ways that we could figure out that unknown amount. Okay, so what you see here is that exact same fraction that I just set up, 25 inches for 1 tablespoon is the same as I don't know how many inches for 5 tablespoons. And what we could do for this first way of solving a unit rate is we could just compare our numbers. I can compare the number 1 to the number 5. And I can think to myself, how did they get there? What did they do to the number 1 to get the number 5? Well, they multiplied it by 5. 1 times 5 is 5. Okay, and because they did that in the denominator, I'm going to use that same strategy in my numerator. So I'm going to go ahead and assume that I can multiply 25 by 5, and that will give me my missing number of inches. Okay, so I would pull that off to the side, or maybe I'd go over to Desmos, and I'd find out what 25 times 5 is. And it is 125. So what does that tell me? That tells me that if I have traveled 125 inches, I must have had 5 tablespoons of sugar water in order to allow me to go that distance. Okay, that is one method that you can use. That's fine. That's called comparing the values, trying to figure out how did I get from one number to the other. Okay, we times it by 5, and whatever you do to the bottom, you do to the top. And there's another way to do this, and this might sound familiar to you guys. It's called cross products. Okay, so the second way that you could go ahead and solve this ratio or this rate is we could cross multiply. And some teachers call this the butterfly technique. I think you guys have probably seen this in some of your classes in 6th grade. Okay, so we're going to cross multiply. We're going to take the 1 and we're going to multiply it by the unknown question mark. Okay, so we are literally doing this 1 times this question mark. I'm going to change that question mark into the letter X, because now that we are in 7th grade, we know how to use variables to represent unknown amounts. So I'm going to call this X inches. Okay, so what I'm going to do is I'm going to go ahead and multiply 1 times X, and I'm going to get 1X. And then I'm going to go ahead and multiply 5 times 25, which I've already done in the last slide. And we know that 5 times 25 was 125. Okay, so we end up with 1x equals 125, and 1x is x, so this is my answer. All right, so this is literally another strategy of solving your proportions. Now, ladies and gents, I'm just going to give you another example. The most common time for you to use this method is when it is not so easy to find out how to get from one number to the other. So I'm just going to give you a basic example. So let's say I had 3 to 4, that's one fraction, and I was comparing it to 10 over I don't know. Okay, so again, this is called a proportion, and we can try to use the other method, which is figuring out how do I get from 3 to 10 using multiplication or division. And I don't really know off the top of my head. 3 times what is 10? I don't know. All right, that's too hard for me to figure out. So instead of using that method, I am going to use that cross product method that I just showed you. So let me show you how that works again. All right, so the first thing I'm going to do is I'm going to cross multiply. It doesn't matter which one you start with. You can go 4 times 10 first, or you can do x times 3 first. It doesn't really matter how you do it. You're going to get the same answer. Okay, so we're going to do 4 times 10. We're going to cross multiply. And we're going to set it equal to the other cross product of x times 3. All right, from here, we're going to go ahead and simplify. We're going to do the math. 4 times 10 is 40. And x times 3 is the same as 3x. We're just going to squish them next to each other. And ladies and gents, don't look now, but we are staring at an equation that we could solve. All right, that's why we learned how to solve equations, so that we could use them to help us figure out math. So what I'm going to do right now is I'm going to try to figure out what x is. I'm going to use the opposite operation of multiplication, which is division. I'm going to go ahead and divide both sides by 3, and I end up with x equals 40/3. Now that cannot be simplified, but I could, if I wanted to, write it as a mixed number. I could do 40 divided by 3. 3 goes into 10 3 times with 1 left over. So I could write this also as 13 1/3. Let's make sense of that real quick. Okay, so what that means in this original fraction is that if I took 3 compared to 4 and I blew it up, and I wanted to say that that's the exact same, that's what an equal sign means, that it's the exact same as 10 compared to some number, I would be comparing 10 to 13 1/3. Right? Our numbers in math aren't always nice and neat. We don't always get whole numbers. You shouldn't be afraid by that. It shouldn't scare you to think you've done something wrong. And that's an example of how you use cross products. All right, ladies and gents, what you are going to do now is you are going to go ahead and jump into Delta Math. All right. This video instruction must watch is what you are watching right now. So you've already completed this. You are welcome to use the Desmos scientific calculator while you are working to help you. If you get stuck and you are struggling, you will see on It's Learning a video link that you can click on that will reteach this to you in a different way. So if you are struggling with the assignment in Delta Math, you are welcome to watch that support video. But what you're going to do right now is you're going to click on Delta Math. You're going to look for ratios and rates, and it should have the date 10/20 next to it. And you are going to go ahead and begin working on ratios and rates. If you have any questions, message me in It's Learning.